So today I will talk about Galilean or the law of conservation of. Today I will talk about that law of conservation of linear momentum. Is invariant under Galilean transformation. So let me talk about it first of all. So what is a law of conservation of linear momentum? Suppose there is one object, it is moving with the velocity u1, and there is another object which is moving with the velocity u2, and say its mass will be m1 u1 and its mass will be m2. So its momentum will be this one. And when they collide with each other, then say this particle will goes like this and this will go like this. Then its final velocity after they interact with each other, it moves with the velocity v1. And say this particle moves with the velocity v2, another particle, and say it will become m2 v2 and it will become m1 v1. Means it's the velocities before collision and these are the velocities before collision. So hence when they are multiplied with their respective masses, that will become a momentum, and the momentum before collision is equal to momentum after the collision. Total momentum or the linear momentum of the system before collision is equal to total momentum after collision. Total momentum of the system after collision. But this is the case when when things are observed from the stationary frame of reference. So I can say that m1 u1 plus m2 u2 is equal to it is m1 v1 is plus m2 v2. So these are the situation when they are seen from the S frame. So but when the things are observed from the S prime frame, then what will happen? In the S prime frame, when the things are seen from the S prime frame and this frame is moving with velocity v with respect to S frame, then in that situation, let us assume that the mass will become this one m1 prime u1 prime, and this for the second particle it is m2 prime u2 prime, and this will go like this way and this will go this way. So it is m1 prime v1 prime and it is m2 prime and the v2 prime this way. Then in the S, this is for the S frame, and for S prime frame I can write down m by m1 prime is equal to u1 prime. Mathematically both the things will remain the same. u2 prime is equal to m1 prime and the v1 prime plus m2 prime and the v2 prime. But as mass is invariant quantity, so I can say that m1 prime is equal to m1 and m2 prime is equal to m2. So I can simply write it down like this: m1 u1 prime plus m2 u2 prime is equal to m1 let me correct it. M2 u2 prime is equal to m1 v1 prime plus m2 v2 prime. So let us put their values. As we know that u1 prime is equal to u1 minus v, and similarly u2 prime can be written as u2 minus v. So similarly I can write down, because velocity is invariant, and using that relation, as we discussed, that the u is equal to u prime is equal to u minus v. That's what we have studied in the earlier lecture. Let me go back. Yeah, as I just did here, it is u minus v. So I basically applied this particular relationship here, and similarly I can write down the v1 prime is equal to, that is v1 minus v, and v2 can be written as v2 minus v. So let us put these values here. So if I put all these values here, then what we are getting, it is m1 u1 minus v plus m2 u2 minus v is equal to m1, it is v1 minus v, and plus m2, it is v2 minus v. Wow, now what I am getting, it is m1 u1 minus m1b m2 u2 minus m2v is equal to m1v1 minus m1b plus m2v2 minus m2v. So this will cancel out with this, and this will cancel out with this. So that means what I am getting, m1 u1 plus m2 u2 and equal to m1 v1 plus m2 v2. So what I did here, I started with the S prime frame and I did little algebra, and what I reached at a point where the law of conservation of momentum in the S prime frame. So starting with this, I am arriving at this particular point, then both looks identical. So that means the law of conservation of linear momentum is invariant under Galilean transformation. That means law of conservation of linear momentum is invariant under Galilean transformation, right? So that's all for this lecture, and in the next lecture I will talk about invariance of the law of conservation of energy, and where I will use the concept of this, that a law of conservation of linear momentum, right? So that's all for this lecture.